Hello everyone, it's Mr. Wolf here, and in this video I am going to go over some information to help you do the WavesLab independently. And this is on pages 3 through 5 of the Unit 8 Waves packet. So for this experiment, we're going to be asking the question, what factors affect the speed of the wave? And when I say the speed of a wave, that's how fast the crest is traveling for a wave. So we're focusing on one crest, how fast that's traveling. And we're going to see, hey, if we change the amplitude, like how high the wave is that going to affect the speed? If we change the tension, so like part of the medium that the wave's traveling through, is that going to change the velocity or the speed? And then frequency, how many times we're generating a wave per second, is that going to change the velocity of a wave? All right, now a few things that'll be that you'll need to do this lab is we need to finish our notes on page 2. So page 2, we took notes here, right, on the very top. On things like velocity, wavelength, frequency, amplitude. If you haven't, make sure to go to the slides or just pause this video and take notes here. But I want to talk about an important thing, which is medium. And so this is a movie poster, Alien. It came out, I think it's like in the 70s. And in it, it has the caption, "In space, no one can hear you scream." So obviously it has that fear factor, but that is actually the case, right? Even in Star Wars, where you're hearing all those explosions, that does not happen in space because in order for a sound wave to travel, it needs a medium to travel through. And when I say medium, just a substance, right? Whether it's gas molecules or water or really anything. But if it's just empty space, you can't have a wave travel. So when we're talking about the medium, it's the type of substance the wave is traveling through, or it could be the quality of the substance. So let's first talk about the type, right? Let's say we have a sound wave. It could travel through air. It could travel through water. It could travel actually through the ground. If you've ever seen a movie where sometimes like someone's putting their head to the ground to see if, there's something happening, right? There's sound waves could travel through the ground, or really any type of material. All right, so we could have different types of material, but we could also have the same material and then change the quality. So for instance, if you're thinking about a string, when you're tuning your guitar, all right, what you're really doing is you're either lowering the tension so it has more slack, or you're increasing the tension where it's more taut, all right? So those are ways that we could change the medium, all right, is we could either change the type a substance, or we could change the quality. And there's multiple ways to change the quality, but a good example is if we want to change the medium, we could change the tension. All right, so on page 3, it's going to give you a setup like this, right? If I even just go right here. And so if you click on this QR code right here, it's going to bring you to this PhET simulation. All right, we want this to be on oscillate. We want this to be on no end. My video's in the way, but we want there to be rulers and a timer, all right? And I want to be able to use that timer. Tension, let's put that to medium. All right, and then damping is at none. Damping is essentially friction. Notice when I have high damping, how the wave essentially the friction essentially causes that energy to dissipate. You don't really see the crest anymore. The amplitude goes down. We're going to say there's no friction. All right, and then we have our amplitude and frequency here. Now, it's going to be tough to make measurements. This is happening really, really fast, so I could do this in slow motion. All right. So here's our setup. If I go to my experiment now and I go to let's see, page 4, what factors affect the speed of the wave? It looks here that we're going to see what effect does frequency have on the velocity of the wave. So how are we manipulating this variable? All right? You're going to have to write this down as I'm talking through it. Let's see. We're going to just adjust this frequency bar. That's it. We're just adjusting the frequency by changing this frequency bar. So for instance, maybe I bring the frequency, I don't know, maybe to 0.75 hertz. All right. So we're going to change the frequency, and we're going to see if that affects the velocity of the wave. How can we measure velocity? Well, if you're running a race, you just measure the time, right? So yes, the units for velocity are meters per second, but for our experiment, we are just going to measure the time, and that'll allow us to know the velocity because we're going to keep the distance the same. So it's the time, how long it takes a crest to travel blank meters. And then we're going to, and so we'll do that. All right. If I go over here, all right, here I got my wave being generated, and it's at 0.75 hertz. And so how are we going to measure that time? So see, I have this timer right here. All right, I'm going to wait till the crest gets to the 0 right up here, and then I'm going to follow that crest until it gets to, let's say the 6 right here. All right, so let's work on that. So it's going up. I pressed go right when it got to the top of the 0 meters right here. Now here's my crest. It's traveling. And it looks like right about here, it got to the 6, 1.58. All right. So I would put that right here. All right, 1.58 seconds for measuring my velocity when the frequency was at 0.75 hertz. So what we could do now is we could change the frequency, we could increase it, and we could see if that's going to change the time at all. All right. Importantly, constants, I should have mentioned this before. If we're changing frequency, the only thing we want changing in our experiment is frequency. So amplitude should stay the same. Your tension should stay the same at medium. Dampening should be the same, right? All those variables are the same. The only thing you're changing is the frequency. All right, lastly, there could be some human error here, right? If I click this timer, like maybe I clicked it like it was just before, just after the 6. So we could have a little bit of variability here. So to control for that, right, when you have your conclusion, right, and let's say, for instance, that the numbers are different. Let's say, I don't know, it's like 0.5, 0.6, 0.7, right? Let's just say that those are our numbers, 0.5, 0.6, 0.7. If you look at that, it seems like things are going up, right? But we're talking about decimal places. That's really, really small. So if it's less than plus or minus 0.3 seconds, that's no difference, right? So if I go to 0.5 seconds to 0.6 seconds, that's really just, like that's 0.1 seconds. It's not a huge difference, all right? Even from 0.5 to 0.7, all right? Yes, it's going up, but again, it's not a huge difference. So I would actually say that those numbers are about the same. If something's increasing, it'll be fairly noticeable. All right, so you could finish this experiment here, and then you could use the exact same just strategy to see how amplitude affects the velocity of the wave. We'll measure the velocity in the exact same way. How the medium affects the velocity of the wave. We'll measure velocity in the exact same way. And think about how could we change the medium? What did I go over earlier in the video of ways that we could change the medium? All right, good luck working on this experiment to see what factors affect the speed of a wave.